Hello and welcome to section 3.3, Properties of Logs. In this section we are going to talk about expanding logs to get them into addition and subtraction problems. We're going to put them back together and we're going to talk about the base change formula. So first one is, these are things that you probably remember from logs that you saw in Algebra 2, but if you don't, remember that if you have a multiplication inside a log, then you are really adding because these are exponents, and if you are if you're dividing, it's subtraction. So we'll talk about this in class and we'll practice it a little bit, but I just want to give you kind of a heads up of what you're going to be looking at and what you're going to see. So when I see a problem like this and it says to expand these, I see that I'm multiplying a times b, so that's going to be an addition problem. So I'm going to write this as log of a squared plus log of b cubed. Now the powers on these could be written out that this thing is a squared, so that's a multiplication in a times an a. So if I wanted, I could write this out as log of a plus log of a, and since there's two of them, I could write it as 2 log of a. Now you may notice that instead of writing it in the blue that I did here in the middle, that I'll put a box around, I don't need to write that out because I was multiplying two a's together, because that's what we were just talking about, the a times the b being addition. Instead of writing this out, I could have taken the little shortcut and put the 2 out front, because that's what I ended up with. So the shortcut, so I don't have to write out plus log b, log b, log b 3 times, I notice that there's a power of 3, so that power could go out front. So I would write this as plus 3 log b. But remember that this is really log b cubed is saying that you're taking b multiplied together 3 times. So I could have written it like log b plus log b plus log b, which is where the 3 comes from when I combine my like terms. But just so you know, you could shortcut it and put the 3 out front. Now this guy over here, to expand it, I notice that I'm multiplying x times this square root. And if you remember that square roots are a fractional exponent, I might want to rewrite this before I do anything, before I break it apart, as log base b of x times x to the 4th plus 2 to the 1/2 power. That will help me out if I think back to what's going on over here with powers. That'll help me out a little bit. I've got these two logs being multiplied together, the x and the x to the 4th plus 2 to the 1/2. So this is one thing being multiplied by another thing. So I'm going to break that apart in addition. So log base b of x plus log base b of x to the 4th plus 2 to the 1/2 power. And since there's addition in here, there's really not much I can do to break that up, but the 1/2 power is a power which we saw in the first example A there, that I can put the power out front to get my final answer of this guy as log base b of x plus 1/2 log base b of x to the 4th plus 2. So this would be the final answer down here in green, and so that's what we're looking at when we are dealing with this problem. Here, this is the final answer, the one in blue. So now we're going to go work the other way, and we're going to put this back together. I notice there's an addition, so that means that the 9 and the 4 would probably be multiplied together. Also, I see that there is 6, so if I wanted, and this is just more of a thought than what actually is happening, is that this is log base a of 4 6 times. And I don't know if I'm going to write it 6 times, but that's what it's really saying. And since it's addition, those are being multiplied together. That's what we talked about in the expanding ones. So those guys are really being multiplied together. So that's the same as taking 4 to the 6th power. So the first move that I would do to put these back together, to write it as a single logarithm, is I would write this as log base a of 4 to the 6th power. Put the power up because that's what's happening here. So now that I have this, I am going to these guys are being multiplied together, the 9 and the 4 to the 6. So my final, well, not really my final answer, but I'm not going to bother to multiply this out, that I have log base a of 9 times 4 to the 6th power. Now if I got out a calculator and figured out what 4 to the 6th is times 9, then that would probably be my final answer. And I'm not going to do that right now. I'm going to leave that for you guys to give me what the final number is when you come to class. So then the next thing that we have is we've been talking about taking logs of bases other than 10 or bases other than e. And remember that log base e is the same as the natural log. So we're going to use the base change formula, which is what you're looking at down here. And really, we could change it to any base we wanted. And this would basically mean that we could use, we could change it to whatever base we wanted. But the two that we can use on our calculator is the natural log and log base 10, the common log. So what we're going to do when we do the base change formula is we're going to change any base into either the natural log or the common log, and you'll see that you're going to get the same answer. So I've got this log base 2 of 5, and I can't calculate on my calculator. So doing the base change using the natural log, I'm going to say log of ln of 5 divided by ln of 2. So the bases go on the bottom and the big number goes on top. And so then over here we could do the common log of 5 over the common log of 2. So if I was to get out my graphing calculator here and find these values, they should be the same. It won't matter. And so at least that's what they tell me, that it won't matter that we're using the different logs. So we'll start with this one. We'll say the natural log of 5 divided by the natural log of 2. Oops, I should close parentheses here. Make sure you do that. Natural log of 5 divided by the natural log of 2. Closing my parentheses. I get that number. And then the other option is common log of 5 divided by the common log of 2. And you can see that it doesn't matter which one we use, but I can now calculate this. And so that means that 2 to some power equals 5, and the power that I'm getting, the x value, is 2.3219280095. And so that's what we're talking about, is that now we can have any base and we can find out what the exponent is. And that's what that's what the base change is doing for us, is helping us find the exponent when 2 to some power equals 5. And so that's what we're going to be doing in class, so please come prepared and ask your questions if you have any in class.